Welcome to the 9.3 video solving quadratic equations. So we are continuing to talk about quadratic functions, but today specifically we're looking at a quadratic equation. We know they're in the form of ax squared plus bx plus c. Our big key today is that the equation is set equal to 0. When the equation is set equal to 0, that means you need to find the solutions of that equation. So when it's set equal to 0, there are such things as solutions, and we will be finding those. This understanding right here says that you can solve them by a variety of methods. Today we will look at graphing and finding square roots. So once again, when it's set equal to 0, that means there are solutions. If you look at this graph that's right here, this is the graph of x squared minus 4. But now it's set equal to 0, meaning find the solutions. An important concept here is that the solutions are the x-intercepts. Remember, x-intercept would be where it crosses the x-axis. So in this graph, it crosses the x-axis here at -2, and then again here at +2. So -2 and 2 are the solutions to this quadratic equation. So once again, the x-intercepts are the solutions. Quadratic equations could have two solutions, such as this one. They could have one solution, or they could have no solutions, and we'll look at that throughout these notes. Some other names for solutions, you can call them the x-intercepts like I just said. You may also call them roots or zeros. So it's important to note that all 4 of those words are interchangeable. You need to know all of them, so in case I say zeros, you know that that means x-intercepts or solutions. So they should be used interchangeably: solutions, x-intercepts, roots, or zeros. Make sure you're familiar with all of those terms. So on this page, we will be solving by graphing. So it says, what are the solutions? Use a graph. We know I need the solutions because it's set equal to 0. So the first thing I need to do is actually graph my equation. So x squared minus 1 is what I'm graphing. There is no bx term. There's not on any of these. So that means my vertex will be on my y-axis, if you recall from an earlier lesson in this chapter. And c tells you your y-intercept. So I know that my vertex will be right here at 0, -1. To find the other points on my graph, I will pick 2 spots over, 1 and 2, for x values to plug into my equation x squared minus 1. So first I'm picking when x is 1, so I will plug that in up here. For x, now I will be saying 1 squared minus 1, so 1 minus 1 is 0. So my next point would be 1, 0, right here. I'm also going to plug in 2, since that's next to 1. X equals 2, plugging it into my original. So I will be plugging in 2 squared minus 1. So 4 minus 1 is 3. This point is 2, 3. Since a parabola is symmetrical, I can copy these points onto this side, reflecting over my axis of symmetry. So I have my points for my parabola now. I can connect them into my U shape. So recall, we're answering what are the solutions. The solutions are where your graph crosses the x-axis, your x-intercepts. So my graph crossed it twice. That means I have 2 solutions. My graph crossed here, where x was -1, and then once again right here, where x was 1. So this graph has 2 solutions, x equals -1, x equals 1, also called the zeros or the roots. Looking at this graph, it's just x squared, no c value, that means it's 0. My vertex is at 0, 0. Once again, I will plug in the next 2 x values. So when x is 1, I will plug that into x squared. So I'm just squaring 1. 1 squared is 1, so my next point is 1, 1. I'll also plug in x equals 2 up here to x squared. So that is 2 squared, which is 4. So this point is 2, 4. Once again, my parabola is symmetrical, so I can also place those points on this side. I can then connect them to make my parabola. So, solutions are where your graph crosses the x-axis. Notice in this first example it crossed it twice, but you will see here there is only one spot. That means this has one solution. It is only crossing my x at one point. In fact, it's sitting right there. It's at the vertex. So that's where x is 0. I have one solution where x is 0. So it's only crossing my x-axis one time. It's not anywhere else. Lastly, I'll go ahead and graph this one. So once again, my vertex will be on my axis because there's no b term. C tells me that my y-intercept is at 0, 1. There's my vertex. Picking the next 2 points, I will plug in when x is 1 into my original up here. So when x is 1, I will be taking 1 squared plus 1. 1 squared is 1 plus 1 is 2. So this point is 1, 2. And then I will also plug in when x is 2 to my original. So y equals 2 squared plus 1. So 4 plus 1 is 5. That point is 2, 5. I will mirror those points on this side and connect them to make my parabola. So once again, hopefully you just went through the point. Once again, the solutions are where your graph crosses the x-axis. Notice that this graph does not cross the x-axis, and it never will. So this is an example where I have no solution or solutions. There are no solutions here because it does not cross my x-axis. Okay, this is its minimum point. The vertex right here is the minimum. The graph is not getting any lower than that. So there is no way it will cross the x-axis. This page is very similar to our last page, except for now, look here, A is no longer 1, but same exact process. So I will start by identifying my vertex. Since there is no bx term, it will be on my y-axis at my y-intercept, which is -6. Okay, so my vertex is 0, -6. I will pick the next 2 x values to plug in, 1 and 2, to find my next few points. So when x is 1, I'll be plugging it in here for x. It is very important that you use parentheses when you are plugging in. So for x, I replace the x with the 1. Order of operations, I would do my exponent first. 1 squared is 1. Now times 2, which is 2, minus 6 gives me -4. So this point is 1, -4. And I will also plug in when x is 2 into my original. Once again, plugging it in parentheses. Make sure you follow order of operations. This would tell me to square the 2 first, which is 4, times by 2, which is 8, and then subtract 6, which is 2. So I get the point 2, 2. I can mirror those points on this side. And then I will go ahead and connect my points to make my parabola. So, this graph will have 2 solutions because you can see that it's crossing the x-axis twice. Now, it does not cross it at an even point, but you can still estimate what they would be. It should be symmetrical, although mine does not necessarily look like it. This should be symmetrical. You can estimate where it's crossing. So I'm going to say maybe about right here, and probably the same for over here. So I would call that x equals, let's go ahead and say about 1.7, and x equals -1.7. So I'm estimating that it's between 1 and 2 where it's crossing. It's crossing twice, so it has 2 solutions. All right, same over here. So in looking at this one, there is no bx term, so my y-intercept will still be on the y-axis, but because it's a 9, I'm probably going to count by something different. So I think I will count by 6s on my y-axis. So this would be 6, 12, 18, 24, 30, and 36. So you can count by whatever will make you fit on your graph. I'm still going to count by 1s on my x-axis, so my graph will be a little distorted based on that. But as long as I'm counting by the same thing all the way on the x and all the way on the y, it's okay. So now my vertex will be at 0, 9, which will be about right here. So my vertex is at 0, 9. I will go ahead and plug in my next two x values, so 1 and 2 again. So when x is 1, I'll be plugging that into here. Remember, make sure you're using parentheses to plug in. So 1 squared is 1, times 3 is 3, plus 9 is 12. So my next point is 112. Okay, I will also plug in when x is 2. So 2 squared is 4, times 3 is 12, plus 9 is 21. So my next point is 221. So that's in between 18 and 24, so I will put that in here. I will go ahead and mirror that on the other side. So negative 1's point would also be 12, and then negative 2's. So I will connect that to make my parabola. So remember, ultimately, since it's set equal to 0, I'm looking for the solutions. So where does my graph cross the x-axis? Well, this one never does. And since this is a minimum, it never will. So this one would have no solution. All right, at this point, go ahead and pause your video. Graph the 3 of these and state their number of solutions and what they are. Remember, solutions are where they cross the x-axis. And then play the video to check that you got it right. All right, go ahead and check your answers. For the first one, you should have one solution where x is 0. On this one, 2 solutions, x is negative 2 and positive 2. And then this one did not cross the x-axis, so there is no solution. You can go ahead and watch video 2 of 9.3 for the next part of the notes.